Hello and welcome back to this fourth session in the Mitigation Hierarchy training series. In this session, the focus will be on the remediative component of the mitigation hierarchy, which covers rehabilitation or restoration, as well as compensation, including biodiversity offsetting. As far as offsetting is concerned, I'll not be going into any detail, given that there is a separate biodiversity offset guideline, a draft of which has been gazetted by the DFFE. So in this session, I will begin with a brief reminder of the distinction between prevention and remediation. I will then move on to discussing remediation and restoration, and I'll finish up with a very brief reference to compensation. As indicated, remediation comprises rehabilitation, restoration, as well as compensation or offsets. And just to stress again that the Mitigation Hierarchy Guideline document provides a lot more detail than what can be covered in these recorded sessions. This mitigation triangular model should be familiar to you by now, including this distinction between the preventative and the remediative components and what they comprise. The threshold between the two, depicted by the red line, is important since crossing this threshold, and reasons to do so, requires careful consideration by the EAP and the specialists. As demonstrated in this slide, moving from preventative measures to remediative measures means that a level of damage will occur preceding whatever strategy is employed after that threshold is crossed. So the move from prevention to remediation should only happen if there is sufficient level of certainty that impacts can be effectively remediated. So I have referred here to the transition from prevention to remediation as crossing the Rubicon. Once the damage is done, you are in the realm of redress, where natural ecosystems can be restored or ecosystem services can be repaired. However, this is done at greater risk and greater cost. There are also implications for stakeholder relations, both in the long and short term, particularly in respect of a social license to operate. Even if stakeholders are convinced that a trade-off may be worthwhile based on delivery of jobs or social infrastructure, a failure to make good on such commitments runs the risk of causing upset, which is made worse in situations where there have been sacrifices in respect of biodiversity and or ecological infrastructure. Finally, it is important to bear in mind that remediative measures do not stem the tide of biodiversity loss. Rehabilitating a site or providing an offset does not add anything. It's effectively a zero-sum game because you are exchanging one thing for another. So one has to be careful about branding offsetting or remediation as making a contribution, because that is not the case. There is no net gain when it comes to like-for-like compensation. So let's focus on the first step in the remediation component, which is restoration or rehabilitation. And this slide explains the difference between the two. So with restoration, the aim is to return a disturbed, degraded, or destroyed ecosystem to its natural condition, with the species present being representative of the ecosystem that occurred on the site prior to disturbance. So inherent in this process is the restoration of ecosystem processes and services supporting the long-term persistence of the ecosystem and species. Restoration may occur as a result of active intervention, but can also take place passively as long as the conditions are conducive. Rehabilitation involves returning an ecosystem that has been disturbed, degraded, or destroyed to sustainable, productive use, but not specifically to its original condition. So with rehabilitation, the aim is to reinstate the ecological processes and ecosystem services. So this slide provides further illustration of rehabilitation and restoration. And what this depiction shows is that there may be a continuum from rehabilitation towards restoration. The rehabilitation measures are then used to facilitate or create conditions conducive to restoration, as can be seen with these rocky berms, which would impede runoff and therefore aid the in situ growth and recovery of natural species. Restoration is preferable to rehabilitation from a biodiversity conservation and protection perspective because you're essentially aiming to reverse the damage that was done to biodiversity and then also the ecosystem services that go with that biodiversity. Key to any restoration project is to plan early and make sure that there are clear and realistic targets. Progress needs to be monitored and all work must be done with the realization that restoration is a long-term commitment. So the example that I've depicted on this slide is an interesting one in that the site here was heavily impacted by urban development. It's in Cape Town, and several years ago a shopping centre was proposed on the site. But opposition during the public consultation process as part of the EIA caused the project to be halted, and then the community became involved in a long-term project to restore the biodiversity in this area. So in this case, the EIA offered an opportunity for communities to think carefully about their priorities and what they value. With rehabilitation, the focus is on repairing or reinstating ecological processes and ecosystem services. So whilst a rehabilitated area might not look or feel exactly the same as before, it should still serve the same function. For example, one could restore a slope by planting exactly the same mix of indigenous vegetation that was there beforehand, but which may take a very long time to re-establish, or one could rehabilitate using an alternative mix of indigenous vegetation that does not replicate original conditions but still performs the same or a similar purpose, such as binding the soil, retaining water, attracting fauna, fire retardation, acting as a carbon sink, or making an aesthetic contribution, and so on. A key challenge that applies to remediative components of a project, be they aimed at either restoration or rehabilitation, is the fact that they must be planned for early on in the project, even if the measures are only going to be implemented further along in the project's life cycle. And this is where the EAP and specialist teams need to draw on their experience and their expertise to anticipate where and when there is likely to be a need for remediation, and then communicate this to the project proponent as well as other stakeholders. So in all instances, explicit and measurable targets must be defined over specific timeframes. And whilst small and relatively low-impact projects can rely on generic techniques and established engineering practices, larger projects, particularly in more sensitive areas, may require more customized solutions. And in this regard, EAPs and specialists should be the ones to determine the baseline conditions and then to set the targets and define the outcomes, preferably in consultation with public stakeholders. EAPs and specialists should also be involved in monitoring. However, with respect to the design and implementation of workable solutions and methods to achieve those remedies, there must be involvement of other professionals, including engineers, designers, architects, planners, landscaping specialists, and so forth. It is critical to have realistic timeframes, particularly when aiming for restoration. The slow pace of restoring ecological processes increases levels of risk and uncertainty, and then time lags can also contribute to cumulative impacts. Finally, a cross-cutting consideration relevant to all of these is again the need to be conservative in estimating effectiveness and adopt a precautionary approach. A good example of the precautionary principle is when one might be experimenting with a novel or untested approach to restoration, but still allowing for potential failure by excluding the mitigation measure from the calculation of residual impacts. Then, if it is successful, there's a benefit, but if not, other measures have been implemented to compensate for biodiversity loss. The need for precaution is also tied to the inevitability of cumulative effects in some areas. This is a major challenge for the EIA process, as it requires thinking about the consequences of a project on a landscape scale over time when there are existing or prospective developments at different stages of planning and implementation, or even at different stages of remediation. As an example, most would be aware of the current impact of mining for diamonds and heavy minerals on the beaches of the West Coast. One of the justifications that's been offered for this mining is that there is a passive process of restoration which will take place gradually and the coastal system will eventually recover. However, when one sees several mining companies operating along adjacent beaches, the cumulative impacts on the landscape and the environment's ability to recover are considerably compromised. And then as soon as there is a measure of recovery, one often sees the same area being remined. And added to that is that the justification of previous disturbance is used as part of the motivation for the renewal of the mining right. Consequently, negative effects are then ongoing and cumulative, such that ecological services are not fully reinstated, with long-term implications for biodiversity, for coastal processes, and then also the stakeholders in the area, including the fishers, the local communities, recreational users, farmers, people involved in tourism, and so forth. This slide provides a theoretical framework for how one might approach the planning and implementation of restoration and rehabilitation. And I'm not going to go through every step. Suffice to stress again that the planning and implementation of remediation is a collaborative effort between the EAPS specialists, the developer, and the engineering and construction teams. It is also important that adequate budget is allocated and costs assigned to each step in the planning and implementation process, including a budget for monitoring and preferably a contingency to cater for unexpected changes or upsets and to allow for adaptive management. The final step in the mitigation hierarchy and the final topic for this session is compensation. The definition provided on this slide is in the Mitigation Hierarchy Guideline and describes compensation as the act of making up or recompensing for loss, damage or injury by providing substitute resources to remedy the harm. In keeping with this definition, biodiversity offsets can be thought of as a subset of compensation. And this makes sense given that there are also other forms of compensation, such as land restitution, alternative infrastructure, alternative means of access, and so forth. I've listed a few key characteristics of compensation, including that it is a measure of last resort, hence its position at the base and the narrowest portion of the mitigation hierarchy triangular model. It is therefore relevant to residual or remaining impacts, and as will be reiterated in the next couple of slides, it is associated with a high risk of being ineffectual compared to previous stages of the mitigation hierarchy. It is also generally much more complex and expensive. I make the point that compensation kicks in when on-site remediation is going to take such a long time that it is still necessary to provide simultaneous compensation, particularly if communities are detrimentally affected or deprived over long periods. And the final point on the slide warns about challenges in holding developers to account for success or effectiveness of compensatory measures, given that they generally are such long-term solutions. Hence, compensation is not something to be taken on lightly or without a good deal of planning, expertise, and buy-in. As per the definition of compensation, biodiversity offsets is a distinct category of compensation, and detailed guidance about the design and implementation of offsets is provided in a separate biodiversity offset guideline. But an important aim of the Mitigation Hierarchy Guideline is to contextualize biodiversity offsets as part of the mitigation hierarchy. The definition of biodiversity offsets stresses that these should be a measure of last resort after every effort has been made to avoid and minimize impacts and rehabilitate affected areas. Therefore, the need for offsetting is determined by the significance of residual impacts. I have also stressed here that offsetting is complicated, difficult, and uncertain. There are relatively few successful biodiversity offset projects that have been implemented to date, and there are also relatively few practitioners that can honestly claim expertise in this area. So in this regard, EAPs need to think carefully about claiming these skills if one hasn't actually gone through the process. It is preferable to seek mentorship and guidance from experienced offset practitioners before embarking on an offset project or advising a client about the potential costs and implications involved in establishing a long-term biodiversity offset. Coming back to the meaning of residual impacts to which compensation applies. Given the dependency of offsets on residual impacts and their significance, assessing the impacts is a key step in determining the need for a biodiversity offset. So residual impacts can be assessed using similar criteria to primary impacts, and there should be a clear and distinct section on residual impacts if and when offsetting or other forms of compensation are being recommended. I have in a previous session noted a tendency to treat mitigation as a kind of magic wand that causes all impacts to vanish or go from high to negligible. A reminder that this tendency is not befitting of a professional EAP who is expected to be careful and honest in their anticipation of the likelihood and severity of residual impacts. The subsequent aim when it comes to compensation is to provide equivalent benefits to counteract residual negative impacts on biodiversity or ecosystem services. The term equivalent is not only a function of size or species diversity, it is very rare to find an exact match, and many other factors come into play, including site availability, level of protection that can be afforded to the site, its accessibility, its cost implications, and then the feasibility of maintenance, monitoring, and so forth. So there are numerous challenges when it comes to offsetting, and in this final slide I offer a summation of these, most of which I've referred to already. And perhaps the most important to highlight is that monetary or in-kind compensation is not equivalent to biodiversity offsetting, and that things like housing, school, clinics, in other words, socioeconomic trade-offs, cannot be offered in lieu of ecological remediation. There have been a couple of court cases where it's been confirmed that this type of community infrastructure cannot be offered in mitigation of biodiversity loss because it doesn't qualify as equivalent or like-for-like compensation. And I'll provide a little bit more detail about that in our next and final session. So thank you again for listening. And in the fifth and last session, we'll be looking at how the mitigation hierarchy ought to be incorporated in EIA reports and in conditions of authorization.